for e, but we're not going to do those. Those are natural logarithms, and that's a number you don't actually know. So, but every number you know, you have to write except for the 10. And remember, the 10 is going to be the only one your calculator is going to give you. All right, so let's try one of these in our calculator. These are called common logs when you have a base 10. Let's see if you can find the log base 10 of 0.01. So in your calculator, you'd more often in your book see it written like this, log 0.01, or you might see it, or you might want to write it, log parentheses 0.01. And in your calculator, you hit the LOG button, and the 0.01, and the enter, and what did you get? -2. Okay, let's see if that makes sense. 10 to the -2 is 1 over 10 squared, which is 1 over 100, and 1/100th is the same thing as 0.01. Yes, it makes sense. Enter, sorry. I made it too small to write the whole enter. Alright, so you can only do that one with the base 10 ones. So let's try to solve an equation now. So let's try to find out log base 10 of 100, and I think you already know what this is, or if you don't, you can punch that one in your calculator. What should this one come out to be? What's log base 10 of 100? Equals 2. Okay, so, but let's say we didn't know that, but that's going to be to verify that. So instead, I'm just going to say, all right, call it equal to x. And now, instead of solving an equation with logarithms, I change this to an exponential. My base is 10. What's my exponent? Which one of these numbers is the exponent? X equals 100. I've changed the logarithm to exponential. Now 10 to the second power is 100. So I can do that one in my head. I can verify that one in my head. But some of these we won't be able to verify so easily in our head. So let's try one that's a little harder. Log base 8 of 16. You can't punch this into your calculator. So what I got to do with this one is set it equal to x and write it as an exponential. So the 8 is my base, the x is my exponent, equals my argument for the log, 16. That one I still can't do in my head. So here's a little trick we'll use. You look to see if both of the numbers in this exponential equation are 2 to some power, or 3 to some power, or 4, or 5. Promise you won't have to go to really big numbers for these powers. So is 8 2 to some power? 8 is 2 to the third power. So I'm going to replace with 8 with 2 to the third, and I got to take that to the x power, so that becomes 2 to the 3x. Now 16 is also 2 to some power. 2 to the fourth. Alright, I got 2 to the 3x equals 2 to the fourth. How do you think I could solve this equation for x now? Any takers? If 2 to the 3x is equal to 2 to the 4th, the powers have to be the same. Yes, ma'am. Yep. If both of these bases are the same, then those powers have got to be the same. So x is 4/3, and we would have spent all day guessing and checking to get that answer right, but if we solve it in an equation, we get it. Okay, gonna move back. Do we get x to the 3, 2 to the 3x equals 2 to the 4th? Okay. Now, if I have, let me give you a little side box here. If I have 5 squared equals 5 to some power, what's that x got to be? 2. If I have 5 to the 4th equals 5 to the 2x, what's that x got to be? That 2x has got to give me a 4, right? So that means 4 has to be equal to 2x, giving me an x of 2. Same thing. Yes, as long as the bases are equal, you can get rid of them and just set the exponents equal to each other. Tricky? Yeah, you want one more of those? Okay, we'll do one even trickier because you'll love tricky problems. All right, so this one's going to be really hard. We're going to solve log base 64 of 1/32. And I'm going to first set it equal to x. Now I write myself an exponential, yes. The exponential is going to be 64 to the x power equals 1/32. Now I no longer have a logarithm. Is 64 and 32 2 to some power? Let's try. If 2's don't work, then try 3's. So 2 squared is 4. Then we got 8. Then we got 16. Then we got 32. Then we got 64. Yeah, so that's to the 3rd, to the 4th, to the 5th. Okay. 64 is 2 to the 6th power. So replace the 64 with 2 to the 6. To the x means I just take that 6 times x. And 32 is 2 to the 5th. Got another way to write 1 over 2 to the 5th power. 2 to the negative 5. Okay, I told you this was going to be really tricky. Now it's easy. 6x equals negative 5. So x is negative 5 over 6.